So just going through this list on the homework, what questions did you guys have? No questions at all. All right. Real quick, I would like someone to explain number 4 to me. So you have scores of 14, 15, 19, and 13 in 4 separate basketball games. How many points must he score in an upcoming 5th game to average 16 points for the 5 game this season? Can someone explain that to me real quick? Keep in mind that you guys are muted. What exactly did you do? First of all, did you get the right answer? Yes. Did you get my class email? Okay. All right. So I'll explain this because this is one that I wanted to go over because this type of question does show up quite a bit. I almost guarantee that you're gonna have a question exactly, at least one question exactly like this. All right. So the first thing that we have to do is to just get the question right. Um, so in every word problem, there's kind of 3 steps, and I'm going to scroll down real quick. Um, we have to know the actual question. So the first thing we do is we read it, and then after we read it the first time, we kind of think about what it's actually asking, right? Then we look at the answers just to see, which ones we can eliminate first, maybe what the odd man out is, and that can help us answer a lot of the time. All right. And then we can also break the problem down into pieces. Luckily, I don't, well, we kind of do need to do that on this one. All right. But this one is asking, like, the actual question is how many points must he score in a 5th game to average 16 points for those 5 games? All right. So I guess we'll start. What is an average? How do you calculate an average? Yeah, so you want to add these 4 numbers and then a 5th and then divide those, right? So we want to add 14 plus 15 plus 19 plus 13. So those are the first 4 games. And we want to see how many he has to score for a 5th game in order to average 16 points. Okay, so we have an average of 5 games on the right, and then that average has to add up to 16. All right, so in this case, then we're solving for x. So does that part right there make sense? Okay, so we're just taking the definition of what an average is, and we're placing in our unknown. All right, so then how do I solve for that? How? Sure. What do you do? Yeah, so what do you get? So why would you get 25 on the bottom? Yeah. Yeah, so you want to multiply by 5 on both sides. All right, and then when you do that, the denominator and that 5 cancel. So you get 16 times 5, which is 80. And then we just subtract out the rest of those numbers. All right, so it'd be 80 minus 14 minus 15 minus 19 minus 13. That's 19. Perfect. Questions on number 4. All right, cool. Any other questions, the ones that you saw that didn't quite make sense? I guess number 6 is a really similar question. All right, so let's do that real quick. John is a lamp salesman. He earned commissions of $24, $28, $21, and $30. If he sells one more this week, how much commission must he earn to average $25 in commission on lamps sold? All right. So again, how would we set that up? How would we set that equation up on number 6? Yeah, so what is our equation going to be? Yeah, so we're missing one number though, right? We're missing our 5th sale. Well, right, but we got to add in that x. So this is what we're solving for now. Right, so we have those 4 sales. And then we're selling one more, and we're trying to figure out what that is going to be. Yep. Yep. Yeah, so what do you get? What? Okay, so what? That's what, 22? Yep, so that's our answer. So questions on number 4 or 6? Okay, good. Uh, are there any other questions throughout those 31? Yep. All right. So number 9. Triangle Construction pays Square Insurance $5,980 to insure a construction site for 92 days. To extend the insurance beyond 92 days costs $97 per day. At the end of this period, if Triangle extends the insurance by 1 day, how much more does Triangle pay for that day than it paid during the first period of time? Okay, so our actual question here is, if Triangle extends the insurance by 1 day, how much more does Triangle pay for that day than it paid per day during the first period of time? So we have to find 2 things. we have to find how much did it pay originally and how much did it pay after that. Okay, so the first thing we have to do is we have to find out how much we're paying per day originally. Okay, and how do we do that? So we have a cost. We have a total cost for those 92 days, right? 5,980. All right, so if we just divide that by our 92 days, yeah, so you get $65 per day originally. Okay, so our original price per day is $65. Does that make sense? Like just getting that number. Do you see how we got that? Okay. To extend the insurance beyond 92 days costs $97 per day. So if we just extend it by 1 day, how much more are we paying per day than original? Well, yeah, so we compare 97 to 65, right? So how much more is 97 than 65? How much more then? So what's the difference between 97 and 65? So you could say that, but even if you did say that, it's not an answer on this list. So then we have to rethink it a little bit. So what's the difference between 65 and 97? Yeah, so that's how you get that answer. Does that make sense? Where doesn't it make sense? Okay. All right, so again, we have to figure out what the question is actually asking. All right, so how much more are you paying for that 93rd day than you do the original 92? Okay, so then we have to do two things. We have to find out how much we're paying per day originally, and then compare that to how much we're paying for that 93rd day. Okay, we're given the 93rd day, that's 97, and we have to find the first 92. Okay. Other questions on any other of the problems? All right, can you hear me? All right, great. Sorry about that. I got cut out. Um, so any other questions on any of the other problems? All right, well, just in case, number 11 is pretty similar, so let's do that together. All right, farmer A sells 30 pounds of tomatoes for $27.60. Farmer B sells the same kind of tomato at a price of $45 for 50 pounds of tomatoes. Which farmer's price per pound of tomatoes is more expensive, and what is that price? All right, so your question is, who has the better deal, and by how much is that deal better? Okay. So how do we find farmer A's average? Oh, whoops, my bad. It's number 11, but it took me out of sharing. There you go. Okay, so number 11, farmer A sells 30 pounds for 27.60. Farmer B sells 50 pounds for 45. How much better and by how much? So how do we find the price per tomato or per pound of tomatoes for farmer A? Yes. Yeah. So when we do that, 30 divided by 2760. Yeah, $1.08. And actually, so we would get 1.08 pounds per dollar. Okay. So that's not quite right. And this is where we got to be careful on this. All right. So when you are calculating a price per pound, our price has to be on top. So you'd get 27.60 divided by 30. So it's 92 cents per pound. Does that make sense? Because that is a little like it's a really easy place to screw up, but it does make a huge difference. We're talking price per pound, not pound per price. Okay, so then we have to do the same thing for farmer B. So it'd be $45 per 50. When we do that, we get 90. All right, so our question is which farmer's price per pound is more expensive? And that'd be farmer A. All right, so we can eliminate C through E. And that price is 92 cents. Questions on number 11. All right, are we positive we don't have any other questions throughout this homework assignment? Because again, these questions are the ones we like absolutely have to get right. So if there were any that you were confused on, please let me know and we can walk through that. Sure. I'll walk through a couple more. Let's do number 18. All right, so number 18 says in thermodynamics, the efficiency of a combustion engine is calculated by dividing the useful work the engine performs by the heat absorbed by the engine from burning fuel, and then converting to a percent. All right, so we have our little equation. Useful work divided by heat absorbed. And then converting that to a percent. Okay, it gives us 453 joules, which is that useful work. and then it absorbs 715. So we just type into our calculator 453 divided by 715. Which is 0.634. So what is that in terms of a percent? Yeah. All right, and then we can try number 16. All right, so the only 3 people in a rowboat weigh 105 pounds, 122 pounds, and 133 pounds. If the average weight in the boat is to be no more than 125 per person, what is the maximum weight in pounds of a 4th person getting into the boat? So how do we set this up? Yep. Yep. And then how do we solve for that? Yep. So then we have 105 500. And then we subtract out all those numbers on the left to get see, I got 140. You guys agree? 140? All right. Yep. $17? Yeah. At a supermarket, apples cost 85 cents each unless 12 or more are purchased, in which case the cost per apple for all apples purchased is 70 cents. Morgan recently purchased 17 apples from the supermarket, but was incorrectly charged 85 cents per apple. How much of a refund is he owed? So again, reading through this, just the question is how much of a refund is he owed, all right? Now, 85 cents per apple, okay, unless you get 12 apples, in which case it's only 70 cents. So what should be the price of 17 apples? So what should be the price of 17 apples? Sorry. And how did you get that? Okay, so that's how much you would have paid, or he would have paid. So 17 apples times 85 cents, and that is what? Great. And what, so that's the price that was charged. What is the correct price though? And how did you get that? Okay, so let's break this down just real quick again. All right. So at a supermarket, you have 85 cents per apple, provided you get somewhere between 1 and 12 apples. All right. So if you get over that, it's automatically going to be 70 cents an apple. Once you go over 12 apples, it's going to be 70 cents. All right. So if you get 13 apples, your overall price is 70 cents times 13. Morgan, this person, purchased 17 apples. Therefore, it's going to be 70 cents per apple. Okay, so it's going to be 17 times 0.7 because it's 70 cents. So when we do that, we get 11.90. Okay, so this should be the price of those 17 apples. That's the overall price. Like, that's the price of all 17 apples. Okay, but she was charged 85 cents per apple, which Carter found out to be $14.45. Okay, now the real question here is how much of a refund do we get? Okay, so how do we find the refund? Yeah, so what do you get? Yes. Okay, so this one again is a little bit trickier because there's a lot of things happening. There's a lot of if-thens, right? So if you buy less than 12 or 12 apples or less, it's 85 cents. If you buy 13 or more, it's 70 cents per apple. Okay. And then you have to compare. So there's really 3 steps to it. Okay. But does that answer make sense? Okay. Let's do 23 and 24, and then we'll move on a little bit. So 23, a phone company charges a fee of 50 cents plus 10 cents per minute for all phone calls. If a single call costs 160, what was the total duration of the phone call in minutes? So how do we set that up? So what's our total price? Yeah, it's $1.60. Okay. So what is the flat rate for a phone call? Like, no matter what, you're always going to be charged at least this amount. Yeah, so this 160 is going to be 50 cents plus, and then what's your price per minute? Yeah, so it's 50 cents plus 10 cents times the number of minutes. Okay, and we'll say X is the number of minutes. Okay, and then we just have to solve that. So how do we solve that? Okay, so how? Not yet. Well, let's look at it, right? So we're multiplying 0.1 by X. So you're right there, but before we do that, we have to get rid of this 0.5. Yeah. So when we do that, we get 1.1 is equal to 0.1x. So how many times does 0.1 go into 1.1? Not quite. When you have 1/10 and 11/10. What's 1.1 divided by 0.1? Yeah. So then this phone call was 11 minutes. Nope. No. So this is asking what the total duration of the phone call is. So X is in minutes, right? That's the number of minutes times the average rate of change. Okay. That would give us like minutes times like cost, I guess. So really, if we have units here, this is $1.6. This is 50 cents. And then this is cents times minutes, right? Well, you would divide 1.1 divided by 0.1. 11 is the answer, right? So once we solve this equation, that's our answer. Yeah, we're just solving for X here. Nope. Does that make sense though? Okay. Yeah. So when you get to a question like this, just set up an equation, all right? Which is sometimes easier said than done, but you should know that like your total price here, it's going to be equal to 0.5 plus 10 cents per minute. And if you can just put that into a mathematical equation and solve it, then you're good. All right. So then let's do 24. For which of the following values of X will 25 divided by X equal 5 divided by 25? So this is a proportion. All right. And really, we just got to solve it. So how do we solve a proportion? Okay, so what do you get when you... Yeah. So then X is equal to what? Oh, wait, hold on a second. You said 125? My bad. That's better. So then how do we solve for X? Yeah, so what do you get? Yep. Great. I want to do one more rate of change one, because we only did one of those. So let's do 25. When Pleasantville Apartments opened, they had 25 apartment units built. If they built an additional 5 units each week, and there are now 135 units, how many weeks have passed? Okay, so what equation would capture that question? So how many apartments were started? Like how many apartments were built as soon as it started? 25, right? And then how many, so we would do 25 plus how many units per week? So 25 plus 5 times the number of weeks. Yep. And then we just solve for X. Okay, so how do we solve for X? And we get what? $110. Yep. So it's been 22 weeks since the place opened. Okay. Any other kind of last second questions on this homework assignment? There are a couple other things in there that we'll get to, like number 30. It has to do a little bit with probability. But we'll get to that a little bit later. Did those questions we went over make sense? Okay. All right, so what I want to do today is, and I don't know if we'll have time for necessarily all this, but I want to go over a little bit of elementary algebra, and actually most of elementary algebra, and then a little coordinate geometry, because they overlap a little bit. All right, so what I'd like to do is going over solving multiple step algebraic problems, simplifying expressions, which are usually going to involve factors and exponents, and then go over equations of lines and their graphs, midpoints, distance, area, which you guys covered a little bit with Mr. Genuine, and then the definition of what a function actually is. All right. So quite a bit to go over. And before we do that, I'll say this. Your homework is in Teams. It is in the class notebook. If you go to content library, linear functions, and weekend homework, it's an entire math test. All right. So what I would like you to do is to take 60 minutes or so, actually time yourself and just try and do as best you can. And then we'll go over any questions on that next time we meet. Okay. So your homework, I'll write it down. Okay, and you should be able to click on that, copy it, and then paste it over into your notebook, or even just write your answers on paper. That's fine too. Okay, but I would like you to try that. Time yourself 60 minutes, and just try and take the test as is, and then we'll go over any questions you have, and then we'll move on with content. All right. So before we do that, I had a couple of questions, I think. I would like you to do in your notebook, just before that weekend homework, there's an intro section. So if you go to linear functions in the content library and then go to the intro page, I would like you to start that. And I'll give you guys, let's say, 10 minutes for the 14 problems. Yep. Linear content library. It's like the third from that. So it goes welcome, collaboration space, and then content library. It's also just on your screen if you want to look at it there. So take another like 10 minutes or so, and then we'll go over them. Let's run through this together pretty quickly. What did you guys get for number 1? D. Apple, do you agree? Yes. Okay. So I got C. So let's do this together. So I'm gonna bring our calculator in. First I want to write this down real quick. All right. Oh, hold on a second. Sorry about this. Okay, well, I can't get this on screen. So when I typed in that into a calculator, I literally just typed it in as is. Right, so 4 times 1/4 times 5 times 1/5. And really, you don't even need a calculator for this. What's -4 times -1/4? When you multiply something by its reciprocal, what do you get? Yeah, it's just 1. And then 5 times 1/5. 1, right? Now, this negative times the negative, that's just 1. This positive times this negative, that's -1. All right, so it's going to be +1 times -1, which is just -1. Do you see how that works? Okay. So some questions like that, they look difficult at first because there's, fractions and negatives everywhere, but really it's just multiplying by reciprocal. And when you break that down, you just get a bunch of 1s. Okay. What about number 2? You got E. Apple. What'd you get? Okay. So let's just check that real quick. 55 times 9. Yeah, that sounds right. And then negative, negative, negative. So the answer should also be negative. Okay. What about number 3? You got D. Okay. Okay, so people got D and people got B. So which one am I hearing? Liam, you said B? D. All right. You got D. All right. So let's check that real quick. So negative 4 and negative 1/2. Times 5/9 times negative 2 and negative 2/3. So I got B when I got it. All right, and I want to show you this calculator and how I got it, but for whatever reason, it's not working. So give me a second on that while I figure it out. In the meantime, what do we get for number 4? You got B. Anyone else? Everyone agree? So it's either going to be B or E, right? So when we do this, we cross multiply. And we get xy is equal to z. So x is equal to z divided by y. So this is so like your guess is on par. It's like almost perfect, but E is the correct answer. Do we see y? So that z will always come first when we're talking about a quotient. Okay. I'm not sure why I can't show my calculator again, but I'm not able to show it. You're gonna have to take my word for it that the number 3 is B. All right, so when we do this, I guess we can do it by hand. Negative 4.5 is negative 4. So the way I wrote it is negative 4 minus 1/2 times 5/9, and then times negative 2 minus 2/3. And when you do that, you get 6.66 repeating, which is 6 2/3. All right, so I would write it out in a calculator like this. And I know it's a little bit kind of jumbled together, but that's how you write that in a calculator. All right, number 5, the sum of 4 and number n all divided by 5 can be expressed as what? Yep. You got E, Apple. Liam. What'd you get for number 5? You had B. All right. So let's look at this. The sum of 4 and a number. So that's going to be 4 plus n, right? All divided by 5 is going to be C. Carter and Liam, does that make sense? Okay. Number 6, if x is equal to 8 and y is equal to 5, evaluate 3x divided by 9 minus y. What'd you get? You got C. Are we in agreement? All right. So let's check it just to make sure. So 3 times 8, that's 24. 9 minus 5, that's 4. So you get 6. Great. What about number 7? You got E. E or B? E. All right. So let's check it. A squared plus B squared, 25 plus 9. $36, right? Oh, there's a b cubed. My bad. I did that wrong then. 25 plus 27. Yeah, you're right. Sorry. It's 52. That's right. I was seeing square right there, not cubed. So you guys are right there. My bad. Number 8, if a is equal to 5 and b is equal to 3, what is 48 minus 6a plus b squared? What'd you guys get? D? Carter? So we have D, we have A. Liam, what do you think? And B. All right. So let's check. So 48 minus 6 times 5 plus 3 squared, which is 9. All right. 48 minus 30, that's 18. 18 plus 9 is 27. So it is D. Does that make sense? All right. Number 9, if a is negative 3, b is 4, c is negative 5, then the product of a, b, c is how much greater than the sum of a plus b plus c? So really this is 2 steps. First we have to find the product, then we have to find the sum. So what do we get for the product? Yes. And what about the sum? Yeah. Yeah. So how much greater is 60 than negative 4? Yep. Liam and Carter, does that make sense? Okay. Okay. And that's okay. Just keep in mind, like this is a type of question that, again, looks probably more confusing than it actually is. So just take an extra 2 seconds. And I know when we're talking about time, that's hard to do. But especially things that don't require like solving for anything, you can take another second and usually get the right answer. Also with a calculator, it's really easy. 3 times 4 times 5, negative 3 plus 4 times plus negative 5, and then take the difference of them. All right. The statement, a number n is increased by twice another number b is equal to 18. So what is that written as? You got B. Carter? Liam? Yeah. Yeah, so number n increased by twice a number, that's n plus 2 times b, and that's all equal to 18. Number 11, the product of 3 and a number n decreased by 15 can be rewritten as what? Yep. Carter and Liam, you agree? Cool. All right. Number 12 is kind of the same. I'm going to skip that. Okay, that's all right. A number n equals 7 more than half the number. So this should be E. Do you guys see how that works? Yeah. All right. And now we get into things that we're really going to talk about. So number 13, simplify. I'm going to erase this box so you can see it. Simplify m squared minus x squared over m squared plus m times x. All right, so this one is a little bit harder because we're talking about unknowns and we have exponents and we have fractions. Okay, so whenever you see a simplify, we're probably factoring some stuff out. Okay, so does anyone know how to factor that top part? Yes, but how would you do that? You can't what? The same variable? Okay, so this is where, and you guys might have seen this last year, but whenever you have something squared, so in this case m squared, and there's a difference of something else squared, you can actually rewrite that as m plus x times m minus x, which seems confusing, but when you FOIL this out, right, you get m squared minus mx plus mx minus x squared. Okay, so these two cancel, and we're left with what's up top. Okay, so you can factor the top part as m plus x times m minus x. And that's just something that it's really helpful to know, especially on the ACT. So if you ever see a square minus another square, you can factor it as the sum and the difference. Have you guys seen that before? Okay, that's just something you got to know. You just like it's way easier to just remember it. Okay, so I'm going to factor that top part as m plus x times m minus x. And what about the bottom part? How do we factor that? Almost. So what are common factors between m squared and mx? Bet. Similar between m and m times x. We can take out an m, right? Right? So we can factor out this m, and what are we left with? On bottom? So if we factor out an m from this denominator, what are we left with? If we factor out m from m squared, what are we left with? What is m squared divided by m? Yeah. When we factor out m from m times x, what are we left with? Yeah, x, right? Mx divided by m, those two cancel. You're left with x. All right. So do we see how we factor the top and the bottom here? Are we sure? Because this is really important. This shows up all the time. Okay. All right. So then we're still not done with the problem. Then we have to cancel out common factors. So what are common factors on the numerator and the denominator? On our factored one. So what's similar between the top and the bottom? Yeah. So when we have things similar in the numerator and the denominator, so long as we're multiplying, we can just cross them out. So then we're left with m minus x just over m, and we get b. Okay. Do we see that? All right. This is, again, it's a little bit more difficult. We're going from elementary algebra to intermediate. All right. Factoring is incredibly important. So being able to take out common factors and rewrite them, it's something that shows up a whole lot, right? So let's do one more. We'll do number 14. So we want to simplify a squared plus 1 over a plus 1. And this one's a little bit harder. This one, when I was reading over this, it took me a couple of seconds to really figure out, right? So can we factor the top? No. Why? Yeah. So we don't have a difference of squares. We don't have, we can't like reverse FOIL anything. Okay. What about the bottom? Can we factor the bottom? Is there a common factor between a and 1? Okay, so we can't factor the numerator or the denominator. So we really can't cancel anything out. So this is as simple as it gets. All right. So our answer here is just none of the above. Do we see how that works? Yeah, there's no common factors between the numerator and denominator. All right, if there were, we'd be able to cancel out and simplify it, kind of like in number 13. But there are none, so it just stays the same. Okay. Apple, Liam, does that make sense? All right. Okay. Let's take. Do you guys want to take like a 5-minute break, or do you want to keep going? Maybe, probably not. I kind of want to get up and just stretch for a second. Tell you what, take 2 or 3 minutes, and then we'll start back up again. All right. So I'm hoping everyone's back. That was a couple of minutes. There are a couple of things I want to go over. Um, we're probably gonna go into like 4:10 or so, and then we'll call it. Um, but there are a couple of different like equations I want to go over, and since we've been talking about average quite a bit, that's the first thing I want to go over. All right, so the average of 2 points, which is called midpoint, which you probably went over during your geometry year, your sophomore year. All right, so midpoint is very simply the average of 2 points. And when you're talking about two numbers, like, right, you're just talking about the average of the two numbers. When you're talking about points on a plane, right, if we have some point x, y up here, and some point, let's say a, b down here, the midpoint, right, the center of this line is going to be the average of the two x coordinates, so x plus a. And since there's only two coordinates, it's going to be divided by 2. And then the average of the y coordinates, so y plus b. And then again, since there are only 2, we divide by 2. All right, so one question that I was looking at, unfortunately it timed out and I can't find it. But it was something along the lines of, what is the midpoint I think of like 17 and 33, which again, when you see it, midpoint, you should just think average. All right, so what is the midpoint of 17 and 35 and 33? Sorry, can someone tell me? Yeah, so what do you get? Yes, yes. So you get 50 divided by 2, which is 25. Good. Okay. And the reason this works is because when we're just talking about two normal numbers, we're talking about a number line. So we're talking about, -1, 0, 1, 2, 3, 4, all the way up to infinity. So we're just talking about a one-dimensional number line. So we're only taking the average of one type of coordinate. All right. Now, if you get something, and I'm going to try and find this question real quick, which I just lost. So one example is, what are the coordinates of the midpoint of the segment whose endpoints are 7, 9 and 1, 1. All right, so now we're talking about something that's two-dimensional. We're talking about a plane. We're talking about a graph, okay? And we have 2 points. We have 7, 9 and 1, 1. So how do we find the midpoint of those two things? Yep. Yep. Simple as that, right? It's the averages of the x's and the averages of the y's. And remember, that first position is always the x, that second position is always the y. And when we do that, we get 8 divided by 2, which is 4, 10 divided by 2, which is 5. So our midpoint is 4, 5. Okay, does that sound familiar? I'm almost positive you guys did this during geometry. All right, great. Do we need more practice on that, or does that seem okay? Good. The other thing I want to go over, which again you guys probably did at the beginning of Algebra 2 and during geometry, is the distance formula. All right, and does anyone remember it? So distance does equal rate times time, but that's in physics. We're talking about just the distance between 2 points. So you are right. Different context though, but that's okay. All right. So distance. Yes. Yeah. So the distance between 2 points is, and I'm gonna write this a little bit so it makes a little bit more sense. The distance between 2 points x1, y1 and x2, y2 is the square root of x1 minus x2 squared plus y1 minus y2 squared. All right, so this is something, even if you don't see this a whole lot on the actual test, you will see it in calculus. You'll see it a little bit in calculus. You'll see it a little bit on the test. You'll definitely see it in pre-calculus. I know that. So it depends on what class you're taking, but you will 100% see this. So a question that will show up is, how far is the point -3, 4 away from the origin? Okay. So how would we set that up? We only have one point in this. What's the other point? Okay, so that's our first point. What's the second point? Well, we do. We just don't know it like super explicitly, right? So we have x1, y1, right? What's x2, y2? It's the origin, right? What's the point of the origin? No, it's just in blue. So when we're talking about a graph, where's the origin on a graph? Yeah, it's 0, 0. Okay, so our second point is 0, 0. So this is x2, this is y2. Okay, so then we have to find the distance between them. So how do we do that? Yeah. So what's our setup here? Yep. And then when we do that, right, this just becomes -3. This just becomes 4. So it's 3 squared plus 4 squared. So we get the square root of 9 plus 16, which is the square root of 25, which is what? That's a square root of 25. Yep. Okay, so, yep. So again, this is just an equation. You should know it, like, by heart. All right, memorize it. I know people, like, have this weird thing against memorizing right now. Just memorize it, because it shows up a whole lot. All right. Questions about distance. Do we want to do one more? Okay. Now, make sure you know it, like, by heart correctly, because even one change of signs is going to get you the wrong answer. Apple, you good on this? All right. Good. Okay. And then the other things we need to talk about are slope, what a function actually is, and equations of lines. All right. So let's start with slope real quick. All right. What is the slope of the line joining negative 4, 7 and negative 5, 0? All right, so how do we find slope between 2 points? Almost. You're almost. You're almost there. All right. What are the two words that you should associate with slope? Like when you're talking about a graph, when you first learned slope, it's what over what? It's rise over run, right? Okay. So rise is always going to be the difference of y's. And then run is always going to be the difference of x. So this is always going to be y2 minus y1 over x2 minus x1. You're almost there, but this is the correct one. All right. So then what is the slope between negative 4, 7 and negative 5, 0? Yes. And what does that simplify to be? Which is just 7, right? Great. Carter, Liam, do we remember slope? Yes, and we're going to get there here in a second. Yeah, slope is like step 1, and then we're going to get to equations of lines. All right. So again, make sure we know this formula for slope. That's very important. You guys should have had a lot of practice with it in Algebra 2, beginning of geometry, Algebra 1. All three of you I had in Algebra 1. I know we went over this. So this should be something ingrained in your head. Okay. The next thing is the equations of lines. All right. And there are a couple of them that I think you should know. Most of you only know one. Okay. And what is that one that you know? That you probably know? Yeah, y equals mx plus b. And what are the different things here? What do they stand for? Which one? Nope. Y is just y. y is the y coordinate, x is the x coordinate. So really our only unknowns here are m and b. M is slope. What is b? Yep. Which intercept? Nope, it's the y-intercept. All right, so on a graph, B is where it crosses the y-axis, and then M is the rise over the run. Okay. So two things you should be able to get from a graph. Its slope and its y-intercept, so long as you can see the y-axis. Okay. The other one that I think you should know is called point slope form. All right, so this one's y-intercept, slope-intercept. Appropriately named because we have the slope and the y-intercept. Okay. The other one is point slope form. And what two things do you think you can get out of this given its name? Yeah, right. You get 1 point and you get the slope. Okay. So this one I always found came in handy because sometimes it shows up in the answers, right? So sometimes you're going to have answers that look like this, and sometimes you're going to have answers that look like this. Well, I haven't written it out yet. But that form is y minus y1 is equal to m times x minus x1. All right. Same thing up on this equation. This y, this front y, and this front x, they just stay there. Okay. This y and this x, that's the point that you're given. All right, so you're dealing with some point x1, y1, and then some slope m. So we're given a point and a slope. Okay. You don't necessarily have to know this. You can definitely survive without it. But sometimes it helps because sometimes answers are written in this form. Okay. And I think there's a question or two like that on the test that you have for homework. All right. But let's do one example of this. Provided I can find it. This keeps timing out on me, and it's really annoying. Okay, so one is find the slope of the line given by 2x plus 3y is equal to 3. All right, so in this, we have an equation, but it's not in any of the two forms that we know. So what do you think we have to do? So this blue equation, right? It's not in slope-intercept or point slope. right? Slope-intercept will only ever look like y is equal to something else. So we have to get this to look like slope-intercept form. So how do we do that? Almost, but we need y on the left-hand side, right? In slope-intercept form, we have y is equal to something else. 3y is equal to 3 minus, well, yeah, negative 2x plus 3. But that's still not just y is equal to something, that's 3y. So what do we have to do? Yeah, by 3, right? So when we do that, when we divide everything by 3, we get y is equal to negative 2/3 x plus 1, right? Does that make sense? Are you guys following along? Okay. All right, so then once we do that, what's the slope? Yeah, it's negative 2/3. Yep. It's that thing attached to x. Okay, does that sound familiar? Again, I know this is late July, so you haven't had a whole lot of math stuff, but this looks familiar, right? Okay, good. All right. Let's do one more. Okay. So the question, obviously, it's multiple choice, but I don't want to have to write all of them out. But what would the equation be for this graph? How would we find that? Either way, so long as you're consistent. Yeah. So you said 1 minus 5. So long as you're consistent. All right, so nope. But x1 is always going to be attached to y1. So long as you're fine with that, then yeah. So you could have done 5 minus 1 over 0 minus 3. That's fine. Then this equals negative 4 over 3, and that's your slope. Okay, so that's the slope. And then from that, you would obviously be able to eliminate a couple of options, right? So like a couple of the answers has y is equal to 1/5, right? That's out of the question. So you'd eliminate those immediately, and sometimes you just have your answer right there. Sometimes you don't, though. Okay, so then we have our slope. What other part do we need for an equation? So we have slope. We have slope. What's the other part that we need? Okay, so what's the intercept? Yep. So what is B? Where it intercepts. Right? It's that green dot. So where's that green dot on the graph? Yeah. Yep. Okay. So this is one situation. So you get that answer, super easy to get. You just find the slope and you can pretty much have your answer. There's not a whole lot of math in finding that B part. You just got to look at the graph and figure it out. Okay. So that really should take you like maybe 10 seconds to do. All right. Now, if your answers look like what you see on your screen, you're good. But what if the answers are all in the form of this? So what if it's all in point slope form? Then what do you think you do? So M is still going to be the same, right? And we already labeled y2, y1, and x2, x1, right? So we just have to replace those things. So then what would our equation be? Right, so Apple, when you said this, what is y2? When you did the slope, what is y2? Y2 is 1. What is y1? Yeah. So then it's y minus 5 is equal to negative 4/3 x minus, and what's x1? Yeah. So that'd be your answer. Right. You could also flip-flop. So instead of x1, it could be x2 and y2. Right. So another answer, and I know this is a little bit overwhelming, but could be y minus 1 is equal to negative 4/3 x minus 3. Okay, so all three of these are possible answers. And again, so when we were talking about the word problems, you know, the first thing is to understand the question. Second thing is to like formulate a plan. And then third is to look at the answers. If you look at your answers and they all look like this, so they all look like they're in slope-intercept form, right? You just find the slope and you find the intercept, you're good. But if they look like point-slope form, like these two bottom answers, you might have to do a little bit more work. You still have to find the slope, right? And then you have to look at your points and determine what's what. Okay. Does that make sense? Have you guys seen that before? Does that like, do you guys understand that? Okay. All right. Now, let's do one more quick thing, and that's parallel and perpendicular lines. All right, so say we have a graph, and say we have this line right here. What would a line parallel to that look like? Yeah. Yeah, either one. We'll pick above. All right, so parallel is going to be in green. What would a line perpendicular to it, perpendicular to red, look like? Yeah, at a right angle, right? So it's going to look something like this. All right. Now, first, you just have to determine what those graphs actually look like. And then, usually the question will have to do with which equation is perpendicular to this line. All right. So when we talk about parallel and perpendicular lines, let's just for a second make up an equation for what's in red. So what would be a good like slope-intercept equation? What do you think? If we just made up an equation, what would it look like? Y is equal to what? The slope's going to be positive or negative? Yeah. So like, we're just going to make up a slope here. Let's say y is equal to 2/3 x. And then our intercept is above the x-axis, so it's got to be something positive. Let's say it's 2. All right. Now, in green, what would the slope of this green line have to be? If green is parallel to red, what does the slope have to be? Yep. So our slope for green has to be the same as red. What about blue? Yeah, but what's the slope? Is it positive or negative? Let's start there. Blue? Yeah, it's going to be negative. All right, so it has to be negative. And then, again, I had all three of you, and I know we went over this. So when we have an opposite, or when we have a negative, when we have a perpendicular slope, it's always going to be the opposite reciprocal, right? So it's going to be the opposite of this positive, and then we're going to flip the fraction. Yeah. Okay. So our slope for blue will be negative 3/2. Green and red will be 2/3. Okay. Does that sound familiar? Again, I'm 99% positive you guys have seen this. Okay. Can I had a couple of good questions on this, and then it timed out on me. Let's shift just a little bit because I'm almost positive we're all right on this line stuff. We'll practice it a little bit more, especially in the tests and stuff. But I want to go over factoring a little bit because that's something that usually people don't grasp too much on the first time. All right. So one question that I have on this test is factor the following completely. And it is x squared minus 6x plus 5. Okay, so when we're talking about factoring a quadratic, how do we start that? Our answers are going to look something like this, right? Yeah, it's a reverse FOIL, but yeah. So how do we get the insides of those parentheses? It's reverse function. All right, so let me show you how I do it. I always look at quadratics as an area of 4 different sectors. All right. This top left is always going to be this guy right here. All right, so what times what is x squared? It's x times x, right? So x squared will go in this little box, and then x goes up here, and x goes right here, right? So if we find the area of that green part, its length is x and its width is x, so its area is x squared, okay? Then we find the bottom right, which will always be this guy right here. So what times what is 5? Yeah, it's 1 and 5, right? So let's put 1 there. Let's put 5 there. And then right, so this length is 5, or sorry, this length is 1. This width is 5. 1 times 5 is 5. All right? Then we fill in the rest, right? So we have these lengths. So this is going to be x. This is going to be x. This is 5. This is 1, right? So if we just finish out this box, x times 5 is what? X times 5, what is it? Yeah. What's x times 1? It's just x, right? Now, we're almost done, right? We know that our factors are going to have an x and a 5 in it, right? So this left-hand set of parentheses, that's the top. This right-hand set of parentheses is going to be the side. And already from that, we can cancel out a couple of options, okay? So from that, you might even be able to get an answer just from doing that little box part, okay? But in order to check and make sure that everything's correct, these two inner boxes, or sorry, the two kind of side boxes, the two red boxes, those have to add up to this middle term. So how would we make that happen? We'd have to get negative 6x, right? So what do we have to do with negative 5x and positive x to get negative 6x? What do you mean by that? You're almost right. And it's not necessarily obvious right up front, okay? The first thing we have to do is make both of these negative, right? So we have to add a negative 5 and a negative 1. That makes both of these negative, and then they add up to negative 6. Right? So then we have to have negative signs up there. Okay, does that make sense? This is a little bit trickier. This is harder to teach on a computer than it is in person. But this is how I do it. Questions about that? Yeah, it's so basically all we're doing is manipulating the sides in order to get the first term and the last term. All right. Okay. Now on the flip end of that, what is b minus 2 squared? Which, yes. Okay, and then if we FOIL that, what do we get? And then we can simplify that a little bit more to get what? B squared minus 4b plus 4, right? Okay. And then one step further, how do we solve for x? Almost. First, you got to do one thing. All right, so when you see this square, the first thing I would do is rewrite it. Kind of like Apple did. Okay, so you have x minus 3 times x minus 3 is equal to 0. Okay, whenever you have the product of two things is equal to 0, what's true of one of the factors? Right, so we have a product of two things here. Yes, it will be. But like, what do we have to do to each of these factors? You have to set them equal to 0. Right? Again, if you have a product of two things and their product equals 0, one of those two things has to equal 0. Now, in this case, they are the same. You're right. And maybe I'm explaining it a little too deeply. But when you set each of these equal to 0, you'd have x is equal to 3 and x is equal to 3. All right. So our answer to that would just be 3. Where that's important to do what I was saying, right? So like if instead of x minus 3 squared, it was four x plus 2 times x plus 1 is equal to 0, you'd have to set both of those factors equal to 0. Right, so you'd set 4x plus 2 equal to 0, and x plus 1 is equal to 0. And then you'd solve, all right? All right, let's do one more, then you can finish up. Let's factor completely y squared plus 15y plus 56. All right, so again, I'm going to kind of do my method. Or you can ask yourself, what factors of 56 add up to 15? All right, so what are factors of 56? We can do it that way. Okay. Do those things add up to 15? I mean, you can, no, that's good. We're still going through factors, but do they add up to 15? No, so we're going to cross that out. What are other factors of 56? 8 and 7. Do those two things add up to 15? Yes, right? So because they add up to this middle term, it's going to be y plus 8 times y plus 7. And then you're done. All right, so if we check that, y times y is y squared. Y times 7 is 7y. 8 times y is 8y. 8 times 7 is 56. And then we have y squared plus 15y plus 56, which is equal to our original question. Okay. questions about factoring, questions about lines, anything like that. Okay, there's one thing we didn't get to that I kind of wanted to, which is exponents, which we will next week. And I know we kind of went through this stuff really fast. Lines are super important. Being able to find slope and slope-intercept are incredibly important. Averages, which we spent a little bit of time on, are very important. And then factoring will always show up. Okay? Questions on any of those things? All right. All right. Your homework for this weekend is to do that test. Again, it's in that content library in linear functions, and then it's in the homework part, and then in that homework page. Okay. Yes. And I'll probably send out an email. I might have to move back Wednesday's class by just a little bit. Probably not, but I might have to. All right. Cool. Apple, we good? Liam, we good? All right. All right. That's all I got for you guys. Yep, no problem. Have a good weekend. Yep.